particular question we are given. So they're saying that the graph of f of x is 3 to the power of negative x. Okay, so this is the graph. This graph, okay, is sketched below. And then they say that A is the y-intercept, so is A. This one is the y-intercept of f, the f graph. B is the point of intersection of f and a line y is equal to y. So basically we have a horizontal line and the line is y is equal to 9, this line. Now this line is meeting with our graph of f at a point B. Okay, this is the point, right? So we have everything that we need. Now let's answer the questions. So 5.1, they say that write down the coordinates of A. Now at A we have a y-intercept, right? So now if we have a y-intercept, we know that we make x 0. So the equation is y is equal to 3 to the negative x. Now if we make x 0, we will see that we will end up with 3 to the power of 0, which is 1. Okay, now from there we see that the coordinates of A is x is equal to 0 and y is equal to 1. Okay, and y is equal to 1. And then the coordinates of B, determine the coordinates of B. Now, how are we going to determine the coordinates of B? Okay, so now at point P, at point B, I mean, at point B, there is a point of intersection or there is a meeting point between two lines. The first one is this one, and then the other one is this one. Okay, so we can use that to determine the coordinates of B by setting up a simultaneous equation and then solving for x and y, and then by that we have the coordinates of B. Okay, we can have the coordinates of B. Let's do that. Now, at point B, we can agree that the equation there is y is equal to 3 to the negative x. Basically, the equation of the exponential function at this point. Okay, because the graph passes at this point, so we can use the equation. And then what we know is that at point B, at B, y is 9. Y is equal to 9. Okay, and then we can use that to actually get the value of x and stuff and stuff and stuff. So instead of writing y, we will write 9, and then y is equal to, or y is equal to 3 to the negative x, and then we have an equation 9 is equal to 3 to the negative x, and then we can say that 9 is actually 3 squared, 3 to the negative x, and now we see that we have what we call an exponential equation. And when we're dealing with algebra, we spoke on how to solve exponential equations. So in this situation, we have made the basis to be the same, so we can equate the powers. Okay, so we can say that 2 is minus x, therefore x is minus 2. Okay, x equals to minus 2 because we'll divide by negative 1 on both sides, and then we will get that x is equal to minus 2. Now we know that the coordinates of B are minus 2 and 9. Okay, and then now they want us to write down the domain of f to the negative f to the negative 1. So in other words, they want us to get the domain of the inverse function of f. Okay, so they want the domain of f inverse, not the domain of this graph, but then the domain of f inverse. Now we have to understand something, that the domain of an inverse graph is the same as the range of the function. So basically, if I can get the range of this function, then I have obtained the domain of the inverse graph. Let me do that. So let me just get the range of this function. We will recall that the range is anything associated with the y values of a graph. So in this situation, from there, from 0, excluding 0, of course, going upwards. The reason why we're excluding is because y is equal to 0 is an asymptote. So the graph is not existing at y is equal to 0 and below y is equal to 0 as well. We don't have a graph. So from there to there, we know that that is the range of our function. So the function that we are working with has a range of y is equal to y is greater than 0. Okay, y is greater than 0. So this is the range of this graph. Now, this translates to the domain of the inverse graph. Now, the domain, remember, the domain is anything or every value, anything associated with the x value, right? So, is all the x values that are associated with our function. So, that makes up the domain of the inverse graph. So x is greater than 0. Basically, it's the very same thing. The thing that we did, we just swapped it. Instead of writing y, we just wrote x, and then the range has changed to become the domain. Because when we are dealing with inverse functions, everything changes. So everything swaps from x to y, from y to x. Okay. So x is greater than 0. This is the domain of the F inverse. Now they are saying we must describe the translation from the graph of F to the graph of H. All right, and H is 27 over 3 to the power of X. Okay, so let's remove. Okay, now initially our graph was 3 to the negative X. Okay, but then now it has changed. Okay, it has changed to this guy, 27 over 3 to the power of x. Now, what we are looking for is how did this graph become that one? Okay, how did this graph change to become that one? Now, we are asking for an interpretation, like a geometric interpretation. Ukuthi, what happened to this guy to become that guy? Okay, we see that the equations are different. Of course, they are for different graphs, but then what happened? Like physically, what happened? Did the graph go two units upwards, two units to the left, to the right? Was it reflected, rotated, or any of that situation? So those are the answers that we are looking for, right? Okay. So let's see. In order for us to do that, let's create a relationship between what we have first. Okay. So um, the graph that we started with is this one, right? 3 to the power of negative x. And then the graph that we have is this guy, 27. And you will agree with me that I'm allowed to take 3 to the power of x to the top and then become 3 to the negative x like this. Okay. Um, and we know that 27 is actually 3 to the power of 3. Okay. So we have hmm, we have 3 to the power of 3 times 3 to the power of negative x, and then we know that if we are multiplying two exponents to the same base, we simply add the exponents. Okay, so it will be 3 to the power of um, 3 minus x, because if I add the exponents, I'll get minus x. And then can I simplify this further? Let's see, 3. And then if I take out -1 in this situation, then it will be like this: negative x minus 3, negative x minus 3. And then, yeah, so this guy has changed to become that guy. Okay, so now we must understand, or we must tell them, what happened to this guy. How did this guy shift to become that one? Okay, now in order for us to understand this, we need to understand the features of an exponential function. Okay, so we spoke about this. We said that an exponential function is given by this form, the form of y is equal to a times b to the power of x minus p plus q. Okay, fix that. Okay, so this is what we are saying. We are saying that y is that. So y is equal to a b to the power of x minus p plus q. Okay, so we can recall that this is the standard form of a exponential function. So we know that a and b determines the shape, and then p the horizontal shift, and q is the vertical shift. We know that one. Now, the only difference between this guy and that one is that there has been a shift. Okay, so you can tell that we shifted, we changed from negative x to negative x minus 3. So in other words, we shifted 3 units to the right. Okay, so we shifted 3 units to the right of the Cartesian plane. So that is the transformation, or the translation, that happened from